Welcome back. This is a continuation of our discussion on creative problem solving. As mentioned before, this is probably the most important aspect or skill that you can pick up is how to creatively solve problems, go beyond what the typical solution is that is available today and try to come up with better and more effective ways of solving problems. That's our job as computer scientists and engineers. Okay, so we've given you an overview in earlier videos. If you haven't watched, it's probably worthwhile to go look at that. What we're going to do in this video, we're going to focus on the first two steps. So our focus would be on figuring out customer needs and issues, as well as writing a problem definition that we could use to guide our work on coming up with a solution. Because and this is probably the first steps are the most important one, because if you're solving a need that doesn't exist or solving a problem that is not the root cause problem, the real problem, then you're kind of wasting all the resources you're putting on this thing. So it's really important to get these two steps right. And it's usually, if you look at companies who are very, very successful, they get these two steps always right, even if they don't get the rest of the steps perfectly right. But the companies that really go weird and are not very successful is usually you will find that they are missing the market by not understanding fully what is the problem they're trying to solve or what they do. So as engineers, you will be part of those organizations. Your job is to help. You don't do it by yourself. You will have help from marketing teams. You will have help from other part of support and sales and regulatory and all the other groups in your company to help you figure this out. But you are also going to be a key member in helping figure these things out. So let's jump right in and talk a little more detail about what a customer needs and issue identification means, how does that work, and how do we write a problem, and really focusing on the fact that a problem definition has 4 components, and it's really important that we distinctly identify each one of the components and have clarity on what those statements and what those each one of those components are for the problem that we are trying to solve. Okay, so let's go ahead and jump right in and take a look at some of the material here. Okay, so if we go in, you'll see that customer need. Let me go ahead and zoom this in just a little bit, maybe make it easier. So where is the customer? So for example, if you work for a company that builds technical tools for engineers, let's say you work for a company like Agilent, who builds instruments, or for engineers, then you yourself are a user of those tools. Or if you work for people like Datadog or some other, or GitHub, or people like that who develops software development tool, then if you're a software developer, you work for that company, then you're building a tool for yourself. So you can literally use your personal experience to guide you in what needs to happen, what are the improvements required, what are the new solutions and services required. But in more cases than not, we are not designing tools for ourselves. We're designing tools for other customers who need us to use. For example, people who design Apple products, those phones are used by a large number of customers. They have to go out there, and they're so large that they have to go out there and survey, serve this set of customers, listen to them, find out what is missing, look at it. So that would be customer survey. Your customer support team always gets concerns and issues from customer, what the customers would like to have that your product doesn't have. Because who do you call when you have a problem? You call customer support. So you want to rely on them to give you more information about how and what you need to improve. Not how, but what you need to improve. And then last, but definitely not least, is competitive analysis. So you can bet, since I'm on Apple, I'll go ahead and stick with Apple. So for example, you know that Apple is taking a look at Samsung and see what Samsung is doing, what they have that they don't have. Samsung is doing exactly the same thing. They are taking Apple products apart. They're probably the first one to buy Apple products when it comes on the market, just to see what new things they're doing. How does that impact their competitiveness, and should they be doing something similar to that or not? That's not cheating. That's just being aware of what your competitor is doing and making sure that you know their weaknesses and you know their strengths, so you can build your business around it. The other place where we get some ideas about what needs to happen is trends, either market trends or technology trends. For example, if everybody likes to have mobile devices, or everybody's looking for virtual reality, that's a market trend and a need that you need to be aware of if you're in that space and start moving your product in that direction. Technology trends would be, for example, if somebody discovers a new way, let's say quantum computing takes off and you're in the computer business, you better be on board. If quantum computer becomes a general purpose computer, it's much more effective than existing technology. I'm not saying it's going to happen, but if it did, then you better be on the ball and start taking advantage of that and start building products based on quantum computing, or else you would be out of business. So these are the places you get ideas if you're an existing company. Okay, if you're a new company, you might have an inspiration. You're something is really bothering you, is not working for you, so you have a passion around something and you use that to guide, and then you have to think about what is the problem I want to solve. Let's say today, for example, here I'll use this example. Today's world, everybody's talking about fossil fuel, global warming, and those kinds of stuff. Now the question becomes, so that would be kind of, if you work for Tesla, that would be improving your electric car. If you don't work for Tesla, your problem statement would be something different. For example, let's say I want to start a company. I really think I see a problem where I have to drive all the way from my home to different places, but all the time I'm in my car by myself. I have not seen a single person car running around, and I don't want to ride a motorcycle. I don't want to do a bicycle because you're going to be in the weather and the rain. So my problem is, so my need is to have a device that is maybe carries, I just want to go by myself. I don't want to waste resources and have a car that has four or five seats, and I don't want to spend $30,000 buying a car. Maybe I can spend $5,000 buying a car. So my need is to get something that just takes one person from point A to point B. I may also be willing to give up some speed. I may be willing to give up, other things, as long as the product is environmentally good and it's helping the environment, reducing our resource waste and cost and all of those kinds of stuff. So that would be kind of the need side. So these, if you work for an existing company, you have all the products that you have legacy, so you're getting a lot of feedback on your legacy, and you got to figure out how to move that forward. If you're a new company, usually you create a new company because you've seen a need or that nobody else is meeting, and you feel like you can do it better than this. That's how new companies come to be. So the next step would be defining a problem. You have all these needs. I want to be able, for example, taking my example to the next step is I just want to be able to carry myself from point A to point B. Maybe I don't want to go very long distances. I just want to use this within Vancouver, so I can go to Stone, I can go to Clark College, I can go to my friends and back, and that's about all I want to do with it. And if it goes 40 miles an hour, no more than 40 miles, I'm okay. I may want it to be safe and other things. So my problem statement at this point, it would be, it depend on how I write my problem statement. I could have lots of different solutions. So potentially the problem statement, if I want to make it really general, so it would be, my problem is I need a efficient way to travel in Vancouver. Okay, without getting cold or wet, etc. The scope is, do I want to build a company around it, or do I want to do it for myself? That would be a definition of the scope. I say, well, I would like to be able to build a prototype. Don't necessarily want to build a company around it, but My scope is to build prototype, one unit, so I can, one option that I can use to test it or use it for myself. I'm not, if it's my scope is to build a whole company on it, that's fine. You can put it, that could be, the scope would be build these devices that build a company. But in my case, I just want to build one just to see, or build one or get a service that does that for me and all that. And the resources I have, I could say I'm an engineer, so I can assign myself to it. I say I'm an engineer working on this one, so I have one engineer, and maybe I'm willing to spend, let's say, $1,000 on it. For material or that kind of stuff. From a schedule point of view, well, if I do this within a year, I will be fine. So maybe I say it would be nice if I had my prototype done in, let's say, right now it's January of 2022. So let's say by January of 23, if I had it, I would be in good shape. Then I have to break this down. I'm going to say this is going to be when I'm going to have it completed. So that means I would like maybe January of 22, kind of maybe finish the definition, define, and maybe in March, I'll have a design, and maybe in July, I will build the first, order the part and maybe put it together for the first time to test. That gives me some time to fix it and all that. You can notice that for the schedule, I went through and broke it down to little pieces. Now I have 4 pieces of this set up there, okay? So when you do a problem definition, it's really, really important to make sure you have a clear statement from a problem point of view. Notice in my problem statement, I never said, is it a car? Is it could be a bus ticket, it could be Uber, it could be whatever. I just want an efficient way to get one person from point A to point B within the Vancouver area, which is, if it goes for 25 miles, that's about maximum I ever travel is 25 miles each way. That gets me to as far off as I want to go. And the scope is I just want to build one item. You might say my scope may have been just design it in a paper, not even build it. That would be another option. Or I want to build a whole company based on it. Those are different scopes. Resources are per person, money you need for material, if you need a special fixture, if you just need a special expertise, something like that. And then schedule would be kind of when it's the end and a few steps in the middle to get me there. Then whenever my design is finished, when I plan to define what the parts I need, when am I going to order it, when I'm going to build the first one, when I'm going to finish testing it, and when I'm going to have the final prototype. So these are kind of the steps to consider when you are trying to define your problem. We will come back and go through the other steps once we've done that. But before we leave this topic, it's also important that think about root cause. And there are a bunch of techniques available for you to find root cause. What does that mean? So root cause comes from the idea that you might have symptoms. For example, you have a let's say your car doesn't run. That's a symptom. It doesn't run. Yeah. But what is the reason it doesn't run? It might be out of gas. It might be, you might have a starter failed. You might have plugged something. You might have low on battery. It could be many, many reasons. Those are the root cause. The reason the car doesn't run, that's the root cause. And here are some techniques available to you commonly that people use, the formal process of figuring out what the root cause is. You ask questions. That's probably the most straightforward. It's called the Kepler-Terego or KT approach. You just keep asking who, what, why, where, questions of yourself, of your team, of your problem, until you get to the root cause of where the problem is. Sometimes there's not one problem, there could be many problems. Survey is another one. You can survey your customer. If it's a big survey, usually is if you have lots of customers, they're sending you different issues over time, and you're trying to figure out if all those issues related to the same thing. You may survey customers to see what they have. A lot of organizations have some products or names, something like voice of customer, where they keep collecting that information and sharing it within the organization so everybody knows what are some of the problems. They use some techniques called Pareto chart. They chart the list of issues based on the number of frequencies they appear and things like that. Statistical processes usually used in the manufacturing. If you have a problem of part not fitting in another part or not working with another part, they keep track of how many went out and create statistical model to see where they're right. Where the issue is failure mode and effect analysis. These are processes where you basically take a look at a problem and see how it impacts the user and try to kind of work your way back. Failure tree analysis is a little bit like the fishbone diagram, where it's a graphical view of how failure of one element can result in other elements. It's kind of a forward view of a fishbone. Fishbone, the reason I call it fishbone is a little bit like a fish, bones in a fish, if you look at it kind of the right way. So if you have a problem, that would be the head of the fish. So for example, my computer is not working, would be the head of the fish. Then you come back and you try to figure out what possibly could be causing that. You have no power. Sure, that could be the reason my computer is not working. Is it the keyboard not working? And you go down this branch and explore the keyboard. If you don't have power, did you turn the switch on your computer? Is your home have power? Is your outlet has power and things like that? And then you come back and say, is the monitor not working? And this is a way of kind of organizing all the possible things that could be the cause of your computer not working on a fishbone. And this way you document, you can go off and check off each one as you verify whether that's the problem or it's not the problem. Experiment and Weeble analysis is just a way of, if you have a problem, just set up an experiment to repeat that problem, and based on that, you try to figure out what potentially could be the problem. The other one, these gets a little more abstract. The benchmarking is useful when, for example, your product is not selling or your product has a problem in the market, but there's nothing wrong, there's nothing functionally wrong with it. Then it may be that other people have better products than you do for something. And this process is called benchmarking. You start looking at how well they do the work, okay? And maybe yours falls short. And then you got to figure out how to bring so your root cause is not because your system is functionally failed, but it's because your product is not as good or as competitive as someone else's. And benchmarking allows you to compare yourself to the rest of the world-class competitors that are out there. Introspection is kind of an obvious one, but we really don't do it as often as we should. We might have the knowledge, but we need to sit down to think about sitting quietly someplace and really in deep thoughts about all the data I've collected and all of that. What does that tell me? And can you kind of try to reason and analyze all the data that you have without trying to reach out and get more information? You want to basically internalize and see if you can come up with a solution based on what you already know. Actually, this introspective is one that we do very little of in a normal course. We are such a hurry. We're trying to look outside. This would be an example of you have a problem, and instead of sitting down and thinking about what your problem is and what you already know that could solve the problem, you get on Google and start searching for someone else to have a solution for you. Where if you had sat down and thought about it, you might have solved it a little faster because you may already have enough information to solve it. So this introspection, even though it sounds pretty obvious, we don't do as much of it as we really should be doing. Okay? That the root cause is basically a good technique to make sure if you think you're working on a problem, it is the right problem that you're working on that's going to solve the symptoms you're observing. And so that's called the root cause analysis. All right. That brings us to the end of this part, which talks about customer needs and the problem definition. See you later.